Yes, can you hear me? आवाज आ रहा है क्या? Yes.
Yes, sir.
Okay.
Yes, sir.
So in the last period, we have proved Carnot first theorem. So today we study efficiency of machine, and that is a Carnot second theorem. Now first we see that is a efficiency of machine. We see the definition and formula for that is the efficiency of a machine. So efficiency is defined as, or efficiency of a machine can be defined as, it is the fraction of, it is the fraction of, it is, that is the ratio of heat absorbed by machine, heat absorbed by machine, which can be converted into work. That is, efficiency of a machine can be defined as, it is fraction of, or it is ratio of, that is heat absorbed by a machine, heat absorbed by a machine, which can be converted into work. Very simple definition is there, that is it is ratio of, or it is the fraction of heat absorbed by a machine, which can be converted into work. So mathematically it can be given as, that is efficiency. Efficiency, what this symbol is known as? Math student, can we ask me that is इस symbol को क्या कहते हैं? It is efficiency. It is here. It is called efficiency. As it is like n, small n. So it is efficiency. Can anybody tell me इस सिंबल को क्या बोलेंगे मैथ्स में? जैसा थीटा है, बीटा है, अल्फा है, वैसा इस सिंबल को क्या बोलेंगे? S. So it is called eta. Eta is equal to, that is a heat converted into work divided by, that is the heat absorbed. So this is the formula for efficiency of a machine. So efficiency is denoted by eta. So eta is equal to, efficiency is equal to heat converted into work. That is how much amount of heat is converted into work divided by, that is heat absorbed. So this is the, that is a mathematical formula for, that is the efficiency, as it is the fraction of heat absorbed by machine, which can be converted into work. Therefore efficiency is equal to heat converted into work divided by, that is the heat absorbed. So this is the formula for efficiency. Efficiency is equal to heat converted into work divided by heat absorbed. So efficiency is equal to the, what is the value of heat converted into work? We have seen in Carnot cycle as well as in the Carnot first theorem, that is RT2 ln V2 divided by V1 minus RT1 ln V3 upon V1. From Carnot cycle and Carnot first theorem, we have taken this here, the values, that is heat converted into work is equal to, that is RT2 ln V2 upon V1 minus RT1 ln V3 divided by V4. Now this whole divided by, that is heat absorbed. Heat absorbed, as we have seen in the, that is Carnot first theorem, RT2 ln V2 divided by V1. So this is the value of heat absorbed. Now we solve this, that is a equation. So but we have seen in the total work done in Carnot cycle, that is V3 divided by V4 is equal to V2 divided by V1. How it come? We have seen, you see in the, that is Carnot cycle, we have seen in detail in that, that is how V3 upon V4 is equal to V2 upon V1. यानी ऊपर के इक्वेशन में जहां पर V3 अपॉन दैट इज V3 अपॉन V4 है, वहां पर क्या रखेंगे आप, दैट इज द V2 अपॉन V1. सो पुट V3 upon V4 as V2 upon V1 in above equation. Then above equation becomes, that is, यहाँ पर देखिए, यहाँ पर V3 upon V4 है, सिंपली यहाँ पे क्या रखना है आपको, V2 upon V1 रखना है. ये कैसा आया, V3 upon V4 is equal to V2 upon V1. We have seen in detail, that is the in Carnot थ्योरम के जो एक्सप्रेशन था वर्क डन का टोटल, वहां पर देखा है हमने. सो efficiency is equal to RT2 ln V2 upon V1. This as it is. That is RT2 ln V2 upon V1. This as it is. This minus RT1. Now ln V3 upon V4. अब यहाँ पर देखिए V3 upon V4 है. But we have to write instead of this V3 upon V4 as V2 upon V1. यानी V3 upon V4 के बजाय आपको V2 upon V1 रखना है. So this is the instead of this V3 upon V4 we have taken, that is the V2 upon V1. Now divided by remaining heat absorbed is as it is, that is the RT2 ln V2 divided by, that is the V1. So this is the, we have put here in the equation V3 upon V4 as V2 upon V1. Now solve this common जो कॉमन टर्म्स हैं उसको कैंसिल कीजिए. नाउ सी दिस इक्वेशन, efficiency eta is equal to RT2 ln V2 by V1 minus RT1 ln V2 by V1 divided by RT2 ln V2 by V1. Now see in numerator which terms are common. In numerator eta is equal to this R and this R is common. We have, this is the numerator. Remember that this is numerator and this is the denominator. So this is the numerator, that is here R is common, R and R. We have taken the R common. Also which quantity is again common here in numerator? This ln V2 by V1 and ln V2 by V1 is also common. We are seeing only numerator. This we are not take ln V2 by V1 because it is in denominator. So R, so this ln V2 by V1 from these two is common. So we have taken outside the bracket. So what remains in bracket? That is the this T2. Here T2 remains. This T2. This minus and this T1 is remains. So in bracket T2 minus T1. Here R is common. So we have taken outside the bracket. And here also that is ln V2 upon V1 is common. So here also we have taken ln V2 upon V1 outside the bracket. So what is that? That equation becomes, and eta is equal to R T2 minus T1 ln V2 upon V1 divided by R T2 ln V2 upon V1. Now see this this term is in numerator and this term is in denominator. Again, which is common here from these two? As see this equation. This equation, eta is equal to RT2 minus T1 ln V2 upon V1 divided by RT2 ln V2 upon V1. So which terms get cancel? S बता सकते क्या कोई? आवाज आ रहा है ना? Can you hear me? S?
Yes, sir.
Okay. So this R and R get cancel. Remember that. This R and R get cancel. ये R और ये R कैंसिल होगा. और क्या कैंसिल होगा? ये भी कॉमन है, देखिए ln V2 अपॉन V1 और ln V2 अपॉन V1 ये भी कैंसिल हो जाएगा. So this R and this R get cancel. ln V2 upon V1 and this ln V2 upon V1 get cancel. So what remains? ये R कैंसिल हो गया, देखिए ये R और ये R कैंसिल हो गया. This ln V2 upon V1 and this ln V2 upon V1 is also get cancelled. So what remains only? This T2 minus T1. T2 minus T1 divided by T2. Only this quantity remains. And this is called as the, that is the efficiency. Efficiency is equal to T2 minus T1 upon, that is the T2. So this is the very important equation, that is when an engine operating between two temperature, that is T1 and T2, its efficiency can be calculated by using the formula efficiency is equal to T2 minus T1 divided by T2. Very simple. T2 means final temperature, T1 means initial temperature. जो टेम्परेचर हाइयर है वो हम पहले रखेंगे, दैट कैन बी टेकन एज T2, और जो टेम्परेचर लोअर है दैट कैन बी टेकन एज T1. So T2 minus T1 divided by T2. So this is the efficiency. This is the efficiency. So efficiency denoted by eta. Eta is equal to T2 minus T1 divided by T2. Remember this equation because this equation is used for solving the problem. Compulsory problem is asked in the examination, that is calculate the efficiency or work done, or calculate the efficiency and total amount of heat supplied to the Carnot cycle. So remember, we see in the next period, that is the numerical problems on this Carnot's first theorem, and that is the efficiency of a machine. So remember the formula, efficiency is equal to T2 minus T1 divided by T2. And this that is T2 is the final temperature, T1 is the initial temperature, and hence efficiency of a machine depends on the temperature T1 and T2. So this efficiency of machine depends on the temperature T1 and T2. That is, it depends upon initial and final temperature and does not depends on the construction of machine. That is, efficiency does not depends upon construction of machine. It is less than unity. So this efficiency is always less than unity. Unity means 1. यानी इसका जो efficiency की जो value है हमेशा 1 से कम होगी. It is always less than 1. So this is about the efficiency. Very simple. That is, definition is there. That is, it is the fraction of heat absorbed by a machine which can be converted into work. So that is, efficiency is equal to heat converted into work divided by heat absorbed. Put the values and solve. Finally, we get that efficiency is equal to T2 minus T1 divided by T2, where T2 is final temperature, T1 is initial temperature, and this value of efficiency is always less than unity. It is always less than 1. Okay, next. Now, next is, we have seen that is the Carnot first theorem. Now, next is Carnot second theorem. First theorem we have proved, that is state and prove Carnot first theorem. So in a similar way, that is state and prove Carnot, that is the second theorem. So we see first the definition of, that is the Carnot second theorem. So what is the statement or the definition of, that is the Carnot second theorem. So no heat engine. See the statement of Carnot second theorem. No heat engine which is operating between two thermal reservoir at fixed temperature can be more efficient than a reversible engine operating between the same reservoir. So this is the statement of, that is the Carnot second theorem. No heat engine which is operating between two thermal reservoir at fixed temperature can be more efficient than a reversible engine operating between the same reservoir. So this is the diagram for, that is Carnot second theorem. This is source T2. This is source T2 and this is sink T1. Now, to prove this Carnot second theorem, that is, we have taken, that is consider two engines. One is reversible, that is denoted by ER, and another is irreversible, that is EIR, working, that is the temperature range T1 and T2. See in the diagram, that is, this is the engine ER. These are the two engine. See in the diagram, we have considered here two engine, that is ER, two engines, but condition is that one engine is reversible. यानी देखिए यहाँ पर हमने दो इंजन लिए हैं, एक इंजन रिवर्सिबल है जिसको हमने ER से डिनोट किया है, यहाँ पे देखिए डायग्राम में ये ER, that is the reversible engine, and second engine, this is the second engine, and it is denoted by EIR. E means capital E means engine and IR means irreversible. Here also E means engine and R means reversible, remember that. So these are the two engine, one is reversible which is denoted by ER, and second is irreversible which is denoted by, that is the EIR. Now suppose that, see, assume that or suppose that irreversible engine is more efficient than reversible engine. हमने यहाँ पे क्या फर्ज किया है, देखिए, assume that irreversible engine is more efficient than reversible engine. यानी देखिए, that is, this is the irreversible engine. We have considered or suppose or assume that is irreversible engine is more efficient. Efficient means that is it is more powerful as compared to other engine. So this we have suppose or assume that is irreversible engine. This irreversible engine is more efficient than that is the reversible engine. Now work produced by that is reversible engine is denoted by WR. Here we have denoted, that is WR means what? Work produced by reversible engine. And here this is the WIR. W means work and IR means irreversible engine. That is work produced by irreversible engine. So work produced by reversible engine is denoted by WR, and work produced by that is irreversible engine is denoted by that is the WR. So now as we have assumed that is irreversible engine is more efficient than reversible engine. So which work is greater? कौन सा वर्क ज्यादा होगा? WR ज्यादा ग्रेटर होगा या WIR ग्रेटर होगा? S, which work is greater? That is work produced by reversible engine or work produced by irreversible engine. As we have assumed that is irreversible engine is more efficient. Irreversible engine is more efficient than that is the reversible. So work produced by irreversible engine, that is WIR, that is W means work and IR means irreversible. So work produced by irreversible engine is greater than, ज्यादा होगा किससे? WR से, because as we have considered that is irreversible engine is more efficient than that is the reversible engine. So consider two engine, one is reversible ER and another is irreversible IR, that is denoted by EIR. Work between temperature range T1 and T2. Assume that is a irreversible engine is more efficient than reversible. तो हमने फर्ज किया है कि irreversible engine more efficient है reversible engine से. It indicate work produced by irreversible engine WIR is more than work produced by that is the reversible engine, that is WR. So this is I have already explained. Now suppose that two engines are coupled, यानी दोनों इंजन को क्या कर रहे हैं? जोड़ दे रहे हैं. So suppose two engines are coupled. The irreversible engine operate in only one direction. जो irreversible engine है क्या होगा वो? It operate on only one direction. The heat transfer and work done can be given as. So that is if the two engines are coupled, the irreversible engine operates in only one direction. The heat transfer and work done can be given as. So see as we have seen in the Carnot-First theorem. So in a similar way, we have to see here that is the heat transfer and that is the. So see the table. Here is the process, heat transfer at T2, work produce and heat transfer. So this is a second column, that is irreversible engine forward. irreversible engine forward. Third column, reversible engine forward. We have to write the values of that. Then fourth column, reversible engine reverse. And lastly, that is the composite engine. Now if one by one, now irreversible engine forward, we write the values of that is irreversible engine in forward. So what is the value of heat transfer? It is Q2 as we have shown in the diagram. So it is Q2. Now work produced by irreversible engine, work produced. So it is that is WIR. We have denoted that work as WIR. W means work and IR means irreversible, and heat transfer is minus Q1. So this is the values of irreversible engine. That is heat transfer is Q2, work produced is WIR, and that is heat transfer is minus Q1. Now reversible engine forward. There are two engine, one is irreversible and another is reversible. So the values of reversible engine forward is Q2, that is heat transfer. Heat transfer is Q2. Work produced, that is the WR. W is the work and R is the reversible. That is, and heat transfer is minus Q1 dash. We have denoted by minus Q1. Now फोर्थ कॉलम सी रिवर्सिबल इंजन रिवर्स. देखिए थर्ड कॉलम में क्या है, रिवर्सिबल इंजन, और फोर्थ कॉलम में भी रिवर्सिबल इंजन. सो व्हाट इज द डिफरेंस? इट इज इन फॉरवर्ड डायरेक्शन एंड दिस इज इन रिवर्स डायरेक्शन. So these are the values of that is reversible engine in forward, and we have to write that is values of reversible in reverse direction. Only we have to take the reverse. यानी आपको इससे पहले देखा हमने, अगर पॉजिटिव है तो नेगेटिव लेना है और अगर नेगेटिव है तो पॉजिटिव लेना है. सो दिस इज आल्सो रिवर्सिबल इंजन and this is also reversible engine, but it is in forward direction and this is reverse direction. Now what are the values of reversible engine in reverse direction? That is, this is forward is Q2, its reverse is minus Q2, यानी यहाँ पे Q2 है तो उसका रिवर्स लेना है, that is the minus Q2. Work is WR, work produced by reversible engine WR, and we have to take in here minus WR, and reversible engine forward minus Q1 dash, and इसका रिवर्स क्या होगा? Q1 dash. So these are the values of that is reversible engine reverse. Now composite engine, how composite engine is obtained? That is, we have to that is subtract the values from reversible engine forward and reversible engine forward. Irreversible minus reversible. So Q2 minus this, यानी आपको सेकेंड कॉलम से थर्ड कॉलम माइनस करना है. सेकेंड कॉलम माइनस थर्ड कॉलम. सेकेंड कॉलम में क्या दिया हुआ है? इरिवर्सिबल इंजन फॉरवर्ड, और थर्ड कॉलम में रिवर्सिबल इंजन फॉरवर्ड. सो Q2 minus Q2. Q2 minus Q2 क्या होगा? Q2 minus Q2, that is 0. So we have taken here 0. सेकेंड कॉलम में से थर्ड कॉलम माइनस करना है. Now WIR, this WIR, this minus this, second column minus third column, WIR minus WR. WIR work produced in irreversible engine, and WR work produced by that is reversible engine. And lastly that is heat transfer. This minus Q1 फिर माइनस होगा, माइनस लेके ब्रैकेट में ये क्वांटिटी आएगी माइनस Q1 डैश. तो ये माइनस और ये माइनस क्या होगा? प्लस होगा, प्लस Q1 डैश होगा प्लस. तो प्लस क्वांटिटी हम पहले लिखेंगे यहाँ, वी हैव रिटन हियर दैट इज द प्लस क्वांटिटी Q1 डैश, ये माइनस, दैट इज द माइनस Q1. सो दीज आर द हीट transfer. This minus Q1 and this minus get plus, and so we have taken first plus quantity, that is Q1 dash minus Q1. Now the composite engine is working absorbing heat from sink, that is the cold body, and remember that sink is a cold body and source is that is the hot body. The composite engine is working by absorbing heat from sink, which is against the second law of thermodynamics, which is the against the second law of thermodynamics. यानी heat always transfer from hot body to cold body. Cold body से hot body में heat नहीं जाती है, तो ये second law के against है. Hence our assumption that irreversible engine is more efficient than reversible is wrong. यानी स्टार्टिंग में हमने जो फर्ज किया था, कंसिडर किया था कि irreversible engine मोर इफिशियंट है, मोर पावरफुल है, किससे? रिवर्सिबल से. सो दैट स्टेटमेंट इज रॉन्ग. तो फिर क्या होगा? देयरफॉर इट कैन बी कंक्लूडेड दैट द इफिशियंसी ऑफ इरिवर्सिबल इंजन मस्ट बी लेस देन और इक्वल टू रिवर्सिबल इंजन. यानी जो दो इंजन है, एक इरिवर्सिबल और दूसरा रिवर्सिबल, तो इरिवर्सिबल इंजन की जो इफिशियंसी है, या तो वो क्या होगी? कम होगी रिवर्सिबल से, या इक्वल टू रिवर्सिबल. यानी दोनों इंजन क्या होंगे? इक्वली इफिशिएंट होंगे, या इरिवर्सिबल इंजन की जो इफिशियंसी है वो लेस देन है, कम है, किससे? रिवर्सिबल से. देयरफॉर इट कैन बी कंक्लूडेड दैट द इफिशियंसी ऑफ irreversible engine must be less than or equal to that is the reversible engine. So this is the proof of that is second law of that is a Carnot's second theorem. I will repeat in short. First we have seen that is the efficiency of a machine. Efficiency, you remember the formula, that is efficiency is equal to T2 minus T1 upon T2. In the next period, we solve the problems on this efficiency and that is work done. So remember, efficiency is equal to T2 upon T2 minus T1 upon T2. Then that is Carnot's second theorem. This is the statement of Carnot's second theorem, that is no heat engine which is operating between two thermal reservoirs at fixed temperature can be more efficient than a reversible engine operating between the same reservoir. So you see in the diagram, this is the source T2, this is sink T1. We have considered that is two engine, one is reversible, that is denoted by ER, another is irreversible, that is denoted by EIR. Work produced by a reversible engine is denoted by WR, and work produced by that is a irreversible engine is denoted by WIR. Now suppose or assume that that is a irreversible engine is more efficient than reversible engine. ऐसा हमने कंसिडर किया कि irreversible engine is more efficient than reversible. Then work produced by irreversible engine must be greater than reversible engine. And if the two that is engines are coupled, then irreversible engine operates in only one direction, that is forward direction. We have seen in the table the heat transfer and work done can be given as. So this is the heat transfer, work produced is given as. And hence finally the composite engine is working by absorbing heat from sink. Sink is cold body, and remember that sink is always cold body and source is always hot body, which is against second law of thermodynamics. Hence our assumption that irreversible engine is more efficient than reversible is wrong. Therefore it can be concluded that the efficiency of irreversible engine must be less than or equal to reversible engine. So this is the proof of that is the Carnot second theorem. Now in the next period we solve some numerical problems. Thermodynamic first के भी हमने solve किए हैं numerical problems. So in the next period we solve the numerical problems on that is a thermodynamic second, that is especially on that is Carnot first theorem and efficiency. So that is efficiency is equal to T2 minus T1 upon T2, and that is work done W upon Q2 is equal to T2 minus T1 upon So this is about the Carnot second theorem. These two theorems are very important because always one question is asked on out of these two, that is the theorem. That is state and prove. State and prove Carnot first theorem. या स्टेट एंड प्रूव कैन नॉट सेकेंड थ्योरम. तो दोनों में से एक कंपल्सरी क्वेश्चन आपको एग्जामिनेशन में आएगा, सो यू प्रिपेयर वेल फॉर दैट. एज वेल एज कंपल्सरी प्रॉब्लम इज आल्सो आस्क्ड on this efficiency and work done. So in the next period we solve that is numerical problems on this topic. तो जब न्यूमेरिकल प्रॉब्लम सॉल्व करेंगे तो कैलकुलेटर, लॉग टेबल और जो है पेन, नोटबुक वगैरह आप साथ लेकर बैठिए कैलकुलेशन वगैरह करने के लिए. ओके.
ओके सर.
इफ यू हैव एनी डिफिकल्टी यू राइट इन द चैट बॉक्स. Okay, we will stop here. In the next period we solve the numerical problem. Thank you.